So like I said yesterday, we'll spend 2 days in 1.2. So today is part 2 of algebraic expressions. What is different about an algebraic expression from a numerical expression? Do you guys remember? Yep.
An algebraic contains variables and a numerical doesn't.
Very good. A numerical expression is just numbers and operations. When we start adding variables to the expression, that's when it becomes an algebraic expression. Very good. When writing an expression to represent a situation, choose a variable to represent each unknown value in the problem. So, some problems you'll be given, and there will be some unknowns. We're going to do what's called defining a variable, where we assign each unknown thing a value or a variable. Okay? Does that make sense? Sometimes the variable will be given to us. Sometimes we have to pick which variable we want to use. Everyone okay with that? Can I move on, or is anyone writing this down? Okay, moving on. So let's jump into an example here real quick. In the group play stage of the FIFA World Cup, teams are placed in groups of 4 and they play each other. A team is awarded 3 points for a win, 1 point for a tie, and no points for a loss. Write an algebraic expression that represents the number of points accumulated by one team in the group play stage of the World Cup. So, this is a situation where we have some unknowns. So I'm going to be flipping back and forth between slides here. So letter A says write a verbal expression for the number of points accumulated and interpret the meaning of the variables in the context of the problem. That's what I want right there. Okay? So, before we do letter A, we need to do what it asks on this first slide right here. Write an algebraic expression that represents the number of points accumulated by one team in the group play stage of the World Cup. So, how many points is it for a win? 3. How many points is it for a tie? 1. How many points is it for a loss? None. So, what would my unknowns be in this case? Well, I know how many points it is for a loss. What do I not know in this situation? How much they scored. Yes. What else? Do we know how many wins each team has? No. Do we know how many ties each team has? No. And do we know how many losses each team has? So I'd say those are our 3 unknowns right there. So we're going to use variables to represent those 3 unknowns. So what variable do you guys want to use for the number of wins for each team?
W.
I heard X, I heard W. I'm going to use W just because that's what the book uses. So if you're looking at the book, you'll see a W. What variable do you guys want to use for the number of ties per team? T. You can use a T. And what do you guys want to use for the number of losses per team? L. I'm going to make a cursive lowercase l so it doesn't look like a 1. Does everyone understand that these are our 3 unknowns in this situation? Okay? So, can anyone tell me what might be a good algebraic expression that I could write that would represent the total number of points each team is going to get in the group play stage of the World Cup? Knowing this information, my variables, and how many points for each thing there are. Can anyone help me out here? What would an algebraic expression look like in this case? points is it for a win? 3. So I would take the team's number of wins and multiply it by that 3, right? So 3W. Can anyone help me out on the rest of that from here? What do I do with the 1T and the 3W? Add them. I want the total number of points, so I'm adding them up. Does that make sense? So 1T or just T. Does everyone understand that if I have a variable just sitting here by itself, there's understood to be a 1 in front of it? Everyone okay with that? Okay. And then, what else for the losses? Plus what? Huh? 0 L. Okay. Well, let's clean this up a little bit. Any number I plug in here for L is going to be multiplied by 0. Anything times 0 is 0. So do I need that 0L there? No. No matter how many losses that team has, it's just going to add 0 points to it. So it's not going to affect my total with this 3W plus T. Does that make sense? Okay. So there's my algebraic expression that is representing the number of points accumulated by one team in the group play stage of the World Cup. Are there any questions how I got that? Okay. Letter A, I'm going to write 3W plus T over here. It's kind of like some of our examples we had yesterday. It wants us to take our algebraic expression and write it as a verbal expression with the context of our word problem. So taking this word problem into account, I need to use some of this verbiage, talking about the soccer teams and their wins and losses, and put it into a verbal expression. So can someone help me out? Writing a verbal expression for the number of points accumulated by each team. So let's substitute the variables for what the variables are representing in our verbal expression. Okay? So what is W representing? Wins. And what's T representing? Ties. So let's reword that. And like I said, replacing the variables with what they're representing. 3 times the number of wins plus the number of ties. Any questions on that? We okay with letter A? So we have given a verbal expression for the number of points accumulated, and we've interpreted the meaning of the variables by telling that, hey, W is wins, T is ties. And that's given with the context of the problem. So any questions on letter A? Everyone okay with that? Okay, letter B. Oh, I'll go back. I'll give you a little more time. I got you. Letter B. What units are associated with the variables, the coefficients, and the expressions? So once again, we have 3W plus T. So let's start with the variables. Essentially, what are these variables representing? Wins and ties. So essentially, the total number of games that the teams are playing, right? So the variables represent number of games What was the next part of the question? The coefficients. What are the coefficients representing? First off, what is a coefficient? Does anyone know? A coefficient is a number being multiplied by a variable. So, on my first term, what's my coefficient? 3. It's the number being multiplied by the variable. Second term, what's my coefficient? 1. Okay? So, what are the 3 and 1 representing? Yeah, the number of points that each team gets per game, right? So, the coefficients represent number of points. And then the expression represents the total number of points that they get. The coefficients represents the number of points per game. And then for the last part, the expression is representing the total number of points that each team gets overall. Does that make sense? Any questions on letter B? So the coefficients are the points per game. The expression represents total points. Everyone okay with that? Can I move on or are we still writing? Okay, I'll give you time. Last part of this question. Once again, we got 3w plus t, right? How would the expression change if a point were deducted for each loss? How would the expression change if a point were deducted for each loss? Remember, right now, it was 3w plus t plus 0l, right? So how would that change if instead of getting 0 points for a loss, a point was deducted for each loss? What would that expression look like? Subtract what? One what? 1L or just minus L, right? Does everyone see that? If a point was deducted for each loss instead, it'd be a -1 here because I'm subtracting 1 for every single loss that team would have, if that was the case. So that would be my answer for letter C. Are there any questions on example 4? A, B, or C? Love word problems, don't we? Can I move on? Okay, algebraic expressions can be evaluated for given values of the variable. The substitution property allows us to evaluate an algebraic expression by replacing the variables with their values. So, this is just one of the key concepts that they have for you in the book. A quantity may be substituted for its equal in any expression. In symbols, if A equals B, then A may be replaced by B in any expression because they equal each other. They're the same thing. That's what equals means, right? So, for an example, if M equals 11, then in the expression for M, I can take the M out and put the 11 in its place to become 4 times 11. Because M and 11 are equal. Does that make sense? So if a variable equals a number, I can replace that variable with that number. Everyone okay with that concept? We're going to be doing that here in a little bit. We're going to be substituting values into expressions and then evaluating what that expression is. Okay? For time's sake, I'm going to go ahead and move on. This chart is in your textbook. Let's look at an example though. So after applying the substitution property to an algebraic expression, you can find the value of the numerical expression by using the order of operations. We did the order of operations in 1-1, right? What are the order of operations again? Someone remind me? Yep.
Exponents, multiplication, division, adding, and subtraction.
Very good. We do all our grouping symbols first. Then we do our exponents. Multiplication and division, we do all of it from left to right. Addition, subtraction, we do all of that from left to right. That's the order we go in. So after we plug our values in, we've just got to use the order of operations to evaluate the problem. So example 5 here, it says evaluate a squared times 3b minus a plus 5 divided by c if a equals 2, b equals 6, and c equals 4.
2 over 2, and then 3 times 6. And then put 2 right there where 8 is. And then divided by 4.
Yeah, very good. So in my expression here, I'm going to use all these values they give me and plug those numbers in for those variables that they equal. So anywhere I see an A, I'm going to replace it with 2. Anywhere I see a B, I'm going to replace it with 6. Anywhere I see a C, I'm going to replace it with 4. We okay with that? So we've got 2 squared times 3 times 6 minus 2 plus 5 divided by 4. Is there any confusion how I've replaced my variables with the numbers that they equal? Any confusion there? So, like it's saying up here, after I substitute those values in, now all I have to do is use my order of operations to evaluate it. So, what's the first thing I need to do on order of operations? Yeah, so that's inside my grouping symbols, right? So I'm doing everything inside these grouping symbols first and foremost. So now I'm looking in the grouping symbols. I'm going to do the order of operations in here. We've got multiplication, subtraction, and addition. What would come first in the order of operations? Multiplication. What's 3 times 6? 18. What would I do next?
18 minus 2.
I would do 18 minus 2, right? Because when I'm doing the order of operations, addition and subtraction are grouped together. I do all addition and subtraction from left to right. So what's 18 minus 2? 16. Everyone okay with my first 2 steps? Now, excuse me, I'm still in that grouping symbol. I've got 16 plus 5. What does that give me? 21. Okay, after I'm done with that grouping symbol, do I have any other grouping symbols with operations going on inside? No. So I'm done with the grouping symbols. What comes after grouping symbols? Exponents. Do I have any exponents? Yes, I do. I've got 2 squared. Remember, an exponent is telling me I need that many of my base being multiplied. So I'm doing 2 times 2, which is 4. We okay there? Any other exponents? Nope. What comes after exponents? Multiplication and division. Grouping those together, working from left to right. So what do I do first now? I'm going to do the multiplication because that comes first before my division. 4 times 21 gives me 84. And now I just have that one operation left of division. What's 84 divided by 4? 21. So the value of my expression when A equals 2, B equals 6, and C equals 4 is 21. We okay with that? So it's kind of applying today's concept with last week's concept or earlier this week's concept of plugging stuff in and then using the order of operations to evaluate it. Any questions on example 5? We okay there? Can I move on? Okay, I'm waiting a second. Last example here. Another word problem for us. In 2004, Chad Fells set the record for the largest bubblegum bubble blown. Assume that the bubble was spherical. The surface area of a sphere is 4 times pi, that little symbol right there is pi, multiplied by the radius squared. Surface area of a sphere is 4 times pi multiplied by the radius squared. So, what would be the unknown in this case?
What the record was?
Well, that's what I'm going to try to find here in just a second. But what else is unknown? The radius of the bubble, right? So, what could we use to represent the radius of the bubble? R. Typically use R for radius. So if I was to write an algebraic expression of this, what would that look like? If I were to convert this verbal expression into an algebraic expression, what would that look like? For the surface area of a sphere. Hint, hint, it is on the board.
4 times pi multiplied radius.
Yeah, just exactly what it says up here, right? 4 times pi multiplied by the radius squared, right? So 4 pi r squared. Does everyone see that? So, part A, complete the table to write an expression that represents the surface area of a sphere. They already filled it in for us, okay? But if it wasn't filled in, you guys would just convert this verbal expression to this on your own. 4 pi r squared helps me find the surface area of a sphere. So, once I know the radius of that bubble, I can plug it in and evaluate and see what the actual record was. Does that make sense?
Yes, sir.
And that's what we're going to be doing on part B. So, part B, the record-setting bubble had a radius of 25.4 centimeters. Find the surface area of this bubble. So 4 pi r squared was our expression for the surface area, correct? So, how do I need to find what the actual record was? How big it actually was, what the surface area of it was. What do I do with that 25.4? Yeah, plugging it in for R. So I'll get 4 pi 25.4 squared. Now, you will be able to use calculators. So I'm going to grab me a calculator real quick. Now, after I've plugged in, I'm using my order of operations to work this problem out. So, here, do I have any grouping symbols with operations going on inside? No. Do I have any exponents? Yeah, 25.4 squared gives me 645.16. And then I'm doing my multiplication here. I'm going to go ahead and do 4 times 645.16, and then I'll multiply it by pi at the end. So that gives me 2580.64 pi. If you guys didn't know it, these calculators actually have a pi button that you could type in. So 2580.64 pi equals 81 point, or actually not 81 point, 8,107 point, we'll round to the nearest hundredth, 32 centimeters squared. Does everyone see that? We just use the order of operations to work this out. So, I had my algebraic expression. They gave me a number to plug in for my unknown. I plugged it in, used the order of operations to evaluate the expression. Okay? Any questions on example 6? We okay there? Question? Okay. We good? All right. We'll get our assignment on Wednesday in class. I'm not going to give you an assignment today. Okay? Do we have any questions about the notes before I end the recording? Okay.